So, hello everybody. My name is Alexander Zemke. I'm one of the developers maintainers of the project called LabPlot. So I'm going to talk about this project soon. And the title of my talk is on the fragmentation in the open source world and the challenges caused by this with respect to the maintenance of such projects. So let me start with, so let me see how to navigate here. Okay, so let me start with some general statements and considerations. So open source community, open source movement. So many people associate immediately, automatically contribution of millions of volunteers, many people across the whole world working, having the same or similar mindset, ideas and vision about how to develop the software, how to distribute it, how to make it available for the society. So there's a big amount of manpower across the whole world contributing to this movement. So while this is of course true for the whole movement in general, this is not necessarily true if you go down to the level of every single project. So we have many projects with a lot of manpower, and we have projects struggling to maintain the project in the long term. So there are different challenges for different projects of different sizes, and there's so like big projects have different problems compared to challenges you have if you maintain a smaller project, and there's for sure an overlap between these challenges. And so there's one important aspect or one important factor that is more critical for smaller projects. Okay, so in general, so if I talk about small project, it doesn't mean we are talking about a trivial project providing some trivial functionality. So if I talk about small or big project, I always refer to the amount of manpower available in this project. So the human factor related to the amount of manpower is more critical for smaller projects. So let me spend some time talking about this. So what many users think or assume usually is, okay, so there's a project I'm using, there's an application freely available, and if I have some feature requests or if I have some bug reports, so I report this, and then there's this expectation, okay, so there are people behind this project that will take care of this, they will implement this new feature, they will work out a fix, will provide the next update, and so on and so on. It goes like this more or less forever, okay, while I'm using this project. So there are always, while I'm using this application, there are always people behind this project who will make sure, you know, this project is still alive. And what people don't understand, not always understand, is maybe, you know, the developers and maintainers behind this project are human beings too. So most of us are working on this project in our free time, spare time, and it's getting more and more harder as if your project gets bigger and bigger, again, bigger with respect to the feature set. So it's getting harder and harder for you to maintain such a project. So you have a limited amount of time. At some point in time, maintaining such a project becomes a work for you. So it starts maybe as a fun, as a pet hobby project, okay, and results in additional work for you. So you're getting more and more professional maybe with your project, and this basically adds on top of the usual stress you have in your life. So it's getting harder and harder, and then people also can have personal interests and motivations that change over time. So people can decide to stop working on this project, okay? And if you don't make sure there's somebody who can pick up the work you did before, if there's nobody else who can continue working on this, the project is more or less done, okay? So this situation is very, very critical for the smaller project where we don't have enough people attached to. So because of this reason, so it's very, very hard for these small projects to safeguard the maintenance, the reliability of the project in the long run. And so this is also my personal impression, so many developers in this open source community heavily underestimate the importance of the invest in the long-term maintenance. And I will talk about a couple of examples on the next slides. So one important problem or one important aspect here in this discussion is the fragmentation of resources or lack of collaboration between the different people working on similar projects. So instead of working together, let's say working together on the same project, combine the available resources that are spare anyway. You know, people prefer to work on their hobby projects, and this is maybe successful for a couple of years, but then because of the reasons mentioned above, you don't manage to continue working anymore on this project, you stop doing this, and this is clearly not a healthy, sustainable situation for your project. So I would like to make these statements now more precise, to quantify them a bit, and I would like to do so by using the examples, by using the project I'm working on, and by using the examples for a couple of other projects that are similar to our project. So the project I'm working on is called LabPlot. So for those who don't know this application, a very quick introduction about it. So LabPlot is a KDE application for interactive graphic and analysis of scientific data. So this is just to get you a brief introduction, so you get an impression about what this kind of application can do for you. So this is an application following the graphical user interface approach. You can import the data into this application. We support multiple formats like ASCII, binary, multidimensional formats like HTML5, feeds, and so on and so on. So you import this data in the application, and you can prepare visualization of it. So we also support live data, meaning so you have data located somewhere in the hard disk or coming over the network from local network sockets, MQTT, or from serial port, and then you basically connect to these data sources, and application visualize the data for you on every data update, basically. So right now we support only two-dimensional visualization, and on top to the visualization we provide also multiple what we call analysis functions. Okay, analysis functions, this can be this can be either fitting, smoothing, fast Fourier transformation, interpolation, integration, differentiation of your data, and so on and so on. So we also provide some basic statistical capabilities. This is actually something, an area where we plan to add much more in the near future. So we also support access to different open source computer algebra systems, being Maxima, Octave, R, or also to dynamic script languages like Python and Julia. So with this, we basically allow to access a huge amount, a very, very powerful set of features provided by these systems. And once you're done with your analysis of data visualization, so you can export the results if needed to different formats, and you can embed them in your publication, and so on and so on. Okay, so this is a very brief overview of the feature set. So if you want to see more, visit our webpage. So here a couple of screenshots. So here you see a typical session of LabPlot. This is the main window. On the left-hand side, you see the what we call Project Explorer, where all the objects you created in this project are shown, and then you basically click with the mouse, select an object, you get the content of this object basically shown in the middle area, in the main area of the application. On the right hand side, you can modify all the properties of the selected objects. So in this specific case, some data, some experimental data was imported in the application, and then we perform a fit by using a certain mathematical function. We perform a fit to this measured data. Okay, so this is how this application looks like, and then you can, once you are done, you can export the results. So here another example of what you can do with LabPlot. Here we are plotting, we are visualizing a mathematical function defined by a certain parameterization. Okay, this is the so-called butterfly curve. Very, very nice example, and I wanted to use it here to show it here in this session too. So I mentioned the access to multiple computer algebra system, and this is how it looks like. So what you see here on the left-hand side is a notebook using Maxima. Maxima is a well-known open source computer algebra system, maybe the most powerful one in this area. And of course, it's also possible to do visualization in these computer algebra systems. Okay, but our approach is basically we do the calculation inside of such a computer algebra system session, and we expose the data, the results of these calculations. We expose this to the LabPlot runtime, and then we basically can visualize the produced data, the results, by using our graphical interface. Okay, in this specific example, Duffing oscillator the properties of the stuffing oscillator were calculated. So this is an oscillator that can develop a chaotic behavior, and then couple of relevant metrics describing this oscillator, this chaotic behavior, visualized on the right-hand side. Okay, enough of advertisement for LabPlot. I hope you got an impression about what this project can do for you. And well, this is not the only project that can do this stuff, so I will introduce shortly a couple of other projects. So when talking about fragmentation of resources and the amount of manpower you have attached to every single project, so somehow we need to quantify this, and I would like to quantify this by using the Git the commit statistics. So here I extracted the statistics from GitHub for our project and for the next projects I'm going to show soon. So what you see here is the history of LabPlot in the last 10, 12 years. Okay, so you see, so the first two top contributors, so those are the, well, basically the two core maintainers of this project, and well, you see the number of commits every day or every week, whatever sampling is used here right now. So you see a constant active work done over multiple years. But again, so only two core developers right now. So we have a couple of other guys, so I'm showing here. So those are our students. So we are participating in the Google Summer of Code for multiple years already. We try to attract new contributors, new students, and by utilizing basically this program. So what you see here are our students. So this guy actually, I mentored him a couple of years ago, and then 1-2 years later, he became a GSOC mentor too. Okay, so this was kind of a success story for us. We managed to enable one person, and this person continued contributing to the project even after his project was finalized. Okay, so this guy was mentoring these guys a couple of years later. So he disappeared then for 1, 2, 3 years because he need university was over. He was done with the university, and then you have your personal life. You need to organize a job. You need maybe to move to another city and so on and so on. So it took some time for him to finalize all this stuff. So he is now returning back, started contributing recently again. So we have a couple of other contributors. Let me show this here again. So a couple of GSOC students here. So this guy is actually one of our users who is quite active with respect to generating new ideas, but also providing fixes and also developing new features. Okay, this is of course an ideal situation when you manage to convert some of your users to contributors. Okay, so you see also this guy, please remember this name, you will see this name later on again. So this is one of the translators in KDE, at KDE, okay, and this is the person helping out all the time to make sure that the translation and localization relevant stuff is properly done in our code. Okay, so this is the situation for our project. Again, 2 core developers, sporadic contributions from other people, and well, this is the status of this project right now. We are not alone. Okay, so there are similar projects out there, and let me spend some time talking about them. So first of the projects I decided to pick here is SciDAVis. SciDAVis is an abbreviation standing for Scientific Data Analysis and Visualization. So actually the history of this project is quite interesting one. SciDAVis resulted as a fork of another project that went closed source 15 years ago, so 20 years ago. So I'm not going to talk about this project. And the 2 guys who forked this project, the original project, they quickly realized, okay, so the code base we have right now, this is maybe not in the best shape. We would like to rewrite everything, but this is a lot of work. Okay, so they quickly realized it's going to be hard. So you kind of understand the amount of the number of features you would like to provide. You understand the overall feature set that this kind of application needs to provide to the users in order to be accepted, in order to have a chance out there. And they quickly realized, okay, we need maybe to collaborate with somebody else. They started looking around, and they encounter, they found LabPlot. Okay, at that point in time, LabPlot had this transition from Q3 to Q4, major refactoring, major rewrite, and actually, so instead of adjusting, migrating the code, so we decided to start from scratch. Okay, we started from scratch, and the SciDAVis guys decided to participate in this. So we used LabPlot's repository. We used this new code where we tried to incorporate all the experience we had from the past, so everything that went wrong. So we wanted to do better. Okay, so we worked together for, I don't know, so maybe 1 year, 2 years, and then so very, very healthy collaboration, very active phase for all of us. And then at some point in time, one of the SciDAVis guys decided to quit this business. So he became demotivated. He had other activities in his life, so the motivation changed, interest changed, and he became demotivated because of the amount of work you need to do to invest here to get the project to a level where you would like to have it. Okay, you can, as I mentioned before, so the overall scope of such a project is very, very clear for all the people working on this project. So most of us have an academical background. So during our university time, PhD times, we worked, or we're still working with this kind of application. So you kind of know the overall feature set. Okay, now if you start implementing the features and you extrapolate to the level what you would like to see for your program, you can estimate the amount of time you need here. Okay, and this was one of the reasons for this guy to quit. So he said, no, I mean, it's taking too long of my time, too much of my time. It will take too long for all of us to become successful. I don't want to do this anymore. Okay, so he quitted this business, and a couple of months later, the second developer of SciDAVis disappeared too. So the second guy didn't even notify us on the mailing list, so there was no personal email sent. He simply disappeared. Okay, not clear what happened to him, and well, at this point in time, SciDAVis was quite popular on SourceForge. Popular with, in the sense of, so the number of downloads for this project per month was very, very high. And SourceForge didn't want this project to die because of its success. Okay, and then SourceForge did some advertisement on their homepage. So they started looking for another maintainer for this project, and there was one guy who decided to take over the maintenance here. So they joined this program, this project, took over basically everything, and yeah, so he became basically the maintainer of this project. A couple of months after this, we reached out to this, and there was maybe 1, 2, or 3 other guys who started working on this project too, because of all this advertisement and noise did by SourceForge. So there were multiple people who took over the work. So we reached out to them and asked for collaboration, and asked to continue the successful and very productive collaboration we had with the original 2 authors of this project, and they didn't show too much of the interest. Okay, so for them, I mean, they were struggling with the overall amount of code and feature set of SciDAVis anyway, and it was hard for them to move on now to yet another project. Well, so the project, I think, is still alive, but doesn't have any big development of new features. So there's more or less maintenance work, so keeping alive what was created in the last years. And yes, so maintenance is still done, but no major development done anymore. And what you see here, so there was some activity done by another user, and so this guy also disappeared here. 2016, so there was another guy who started contributing here and was not quite happy with the overall architecture of this code, so he decided to fork this project. Okay, like one of the problems in the open source community, so you don't talk to each other, you fork the project. Okay, I'm not saying this is always the case, but this happens from time to time. So this guy forked SciDAVis and created AlphaPlot. Okay, so this is now a screenshot and a statement, the description from this from the homepage of this project. So this is how a typical session looks like in SciDAVis and AlphaPlot. So they have more or less the same feature set, and what is being done here, or what was done here, basically this guy decided to move to another plotting library here. So instead of using the code, the old library that was used by SciDAVis, he wanted to use something that is more modern, providing more features and having more maintenance and so on and so on. Okay, this is basically the refactoring done by this guy here, and then adding more and more features. Again, similar situation here, so quite some excitement and activity at the beginning. And this is what I always referring to. So it's very, very very easy to start a project. Okay, so you are very motivated, you are eager to develop something. It's very easy to do the first steps during this development, during this excitement phase. Okay, but then at some point in time, you run into this saturation phase where it's not so easy anymore to do the next steps. Okay, you have technical challenges, you get challenges because of your personal life, because of the limited amount of time, and so on and so on. So all these factors I described in the beginning, so you run basically into these problems at some point in time. Okay, and this is what we see here. So after this excitement phase, after this very active development phase, it went down. So there was nothing done anymore. And then you see these different phases, you know, where this one single person finds where this person finds some time to contribute to. Okay, so big breaks in the development of this project. Again, some live shown here, and but more or less, you know, so one-man project to no further contribution from other people. So there's one more project to mention here. So this is called Veusz. I would say, you know, out of this project mentioned here, this is maybe the project with the biggest amount of feature sets, having also the longest history here, maybe. Also more or less a one-time project. Okay, this is a guy from academia who apparently has enough time to continue working on this project, working on this project already for many years. So the project is still active, still maintained. And a couple of years ago, so I reached out to this guy and asked for collaboration. Like, you know, so we are working on the same functionality. We are using Qt, you know, so there's a lot of stuff maybe to be shared. So let's come together, let's work together on something that is much bigger than compared to what we have right now in our projects while working alone on them. So this guy didn't show too much of an interest, you know, and then we went different ways, separate ways again, and continue working on our projects alone. So also here you see, so this is more or less one-man project. So one more project to mention here. It's actually another project from the KDE community. It's called CaseTeam. So this is also a project having a very long history, and this project is known for its speed. Okay, so the statement I took here is from their homepage. And you see here a typical session where some live data is visualized, so incoming data in high frequency is visualized, and then certain analysis functions like smoothing maybe is applied, you know, and then you get basically this kind of visualization. So let's check the activity for this project tool. So also here, more or less the same situation. We have 1 to 2 developers contributing to this project. So one developer who managed to work for a substantial amount of time, managed to contribute to this project, and he more or less disappeared 2 years ago. Okay, so right now there's nobody else who can pick up this project. So there are several emails sent to the mailing list, users asking for updates for some maintenance related work, for new builds for Windows, for new versions of Windows, and so on and so on. Okay, and there's more or less nobody who can reply, who can take over the work that was done by these guys here. Okay, there was another guy who was quite active, who has his active phase disappeared completely too. Okay, so right now this project is not, I would say, not alive anymore. Okay, as a short summary maybe, so what you see here, so for this kind of applications, we see a very fragmented distribution of development resources. So we see mostly 1 to 2-man projects, and these different projects have different speed of development. For LabPlot, I would say right now we have very, very active, very healthy development phase. So these two developers, including me, so they showed before, are working very well together. So it's a lot of fun developing, working together here. So we are, I would say, very, very productive, very, very effective right now. So there are no bigger discussions. So we are highly aligned, very productive mode right now. No conflicts. But it's clear, this won't go on forever because of the reasons I mentioned at the beginning. So we still need to think about what to do, how to do the project setup properly, so we don't run into the situation like for a couple of other projects I showed before. And also right now, so even being very effective, very productive, we are still very limited with respect to our time. Okay, so we know what, as I mentioned before, so we know very well what needs to be done, what we need to develop, what our users are expecting from us, also either by comparing ourselves with other similar open source projects or even with commercial projects that have a very, very big feature set. So we know pretty much what needs to be done here. Okay, and then we again kind of extrapolate the amount of time we would need here, and then we realize, okay, this will take us years, many years to get to this level. Okay, so somehow we would like to speed up this development. So being effective, being productive is not enough here. So the amount of manpower we have here is not enough to do the next steps. So we would like to bring the project to the next level, and having the resources available right now is maybe not enough. So we would like to change this current situation. So these challenges I mentioned before, so we would like to address them somehow. So we want to do the next step in the development of the project, and we want to make sure, so we have this healthy situation in the project going on for many years in future. So what we are doing here right now. So we are looking for synergies and collaboration with other projects. So with other projects, so I'm not referring anymore to the projects I mentioned before, because here the situation is clear. So they are either not active anymore, or we already reached out to them. There was no big interest to collaborate. Okay, so I don't think so. We are going to reach out to these guys again. So we are looking here basically for other projects or for other frameworks, libraries that we can utilize, that we can use in our application, that would help us to speed up basically the development of the project. So we also would like to intensify the activities within KDE, within our organization. So those activities are basically around packaging of the software, distributing it through various app stores like Microsoft Store, Apple Store, and so on and so on. So we have we would like, or we are already making more use of the build artifacts produced on the build infrastructure at KDE, like, so there's an installer provide nightly installer, nightly build. So there's installer provided for Windows, there's an image provided for Mac OS users, and we do a bit more advertisement around this build artifacts. We invite users to test, to use our nightly builds, not only on Linux, where the situation is more clear, right? So we also want to attract. So we realized actually, so we have many users coming from the Windows world, and we don't want to block them, don't want to completely ignore them. And now we are also inviting more and more of these users to test their nightly builds. Okay, and the results for this are produced on the centrally available infrastructure at KDE. So we also the documentation we have right now, this is definitely something that is not on the level where we would like to have it. And also here, so we are looking for some synergies, collaboration within the KDE organization. Yes, maybe I would like to make a short pause here. So I mentioned the infrastructure, built infrastructure. And so there are many people working behind the scenes, contributing to the success of our project, or to the success of other projects at KDE. So people are taking care of the built infrastructure, people taking care of the promotional work, documentation, translation, localization of the application, and so on and so on. So these people are usually not the front men of the project, so they are not visible in many cases. Okay, but they are definitely there, and they're contributing a lot to the success of this project. And I think so all these guys deserve deserve a lot of appreciation. So let me use maybe this opportunity to thank all these people working in these areas. So I really appreciate the help, guys, you are doing here. So Ben, Yuri, Paul, Carl, so many others doing their work behind the scenes. Thank you a lot. Same, of course, for the organizers of this event, so Alison and other people. So thank you a lot. So to improve the overall the current situation right now, so we also plan to increase the frequency of releases. So this is one of the problems we have right now, where we didn't pay enough attention maybe in the past. So we release when we consider the current new feature set to be big enough, and so there are no regular releases right now. So we do a release once per year, so less than a year maybe, and this is something that we definitely need to change. So we are releasing in big bunches, and we should do this a bit different. So we should release more frequently, and because releasing getting additional attention to your projects anyway. So, and we want to invest more into the promotion work to attract new contributors. So having not enough resources, not enough contributors is a challenge for this kind of project, for the small projects. Okay, and this is definitely something we need to change by attracting new people to the project. So I mentioned Synergies, and working together, collaborating with other projects, and maybe just to give you one example. So what I'm showing here is Cantor. Cantor is another KDE application. It's a front end to different mathematical applications, to the different open source computer algebra systems like Maxima, Octave, and so on and so on. Okay, this is what I mentioned in the beginning, and this is one of the Synergies, one of my examples I'm usually referring to in this context. So this is where we had a big additional value we added to Laplate because of the collaboration between these two projects within KDE. So this is now another project where I'm contributing to, also mentoring GSOC students. So this is a standalone application, okay, but what we did basically, so we embedded the runtime, we embedded this application into LabPlot. We enabled this connection between the computational part of this application and the visualization part of LabPlot, okay, and then with this we basically enable completely new workflows and provide a big additional value to our application. Okay, so this kind of synergies, this kind of collaboration, this is what we are looking for here basically right now. I mentioned the promotional work. To be honest, so there's a certain change in the mindset happening on our side. Okay, so we plan to invest more in this direction now, and I don't want to say we completely ignored the promotional part in the past, okay, but I would say we heavily underestimated the impact or the importance of this promotional work. So somehow you have the impression, or you have this perception, you're writing the best code ever, so you're working on the most coolest features, so you're much better than your direct competitors, and so all these users you're trying to address, so they will automatically come to you. Okay, this is kind of a mindset we had in the past, okay, and this didn't go well. Okay, this was of course correct to a certain extent. Okay, we managed to attract a certain amount of users, okay, but this is not enough, and we didn't manage, so following this strategy, this philosophy, we didn't manage to attract any new contributors. Okay, so this is now something where we would like to change. So we started investing into the documentation, example, tutorials, and so on and so on. So this is something that was not didn't get enough attention from us in the past. We also invest now into the UX part of the application. So we need to make sure the application is not only usable by us, but also by many other newcomers here. So actually, there was a comment on one of the Reddit articles published by the KDE promotional team, and one of the users, the comment was like this: okay, so I installed LabPlot, looks great, so the screenshots on the homepage look great, but I don't see how to visualize, how to import and visualize the data. Okay, and this was kind of a well, this was a very critical comment, at least for me, you know, so because you are working on this application for many, many years and everything is very, very clear to you. So you know how to import the data, how to visualize, and you assume everything is very, very easy to understand. And then you are confronted with such a statement from a newcomer, from a new user, okay, and then you see, okay, people don't manage to work with your application right away. So you need additional help, okay, and this is something where we need something that we take very, very seriously and try to improve now. So the overall plan is, of course, to attract new contributors, to add, to convert. Ideally, we manage to convert some users of this application into contributors. So mostly the users in this community have the required technical background, so they have the technical skills, okay, and then if these people have already some skills in C++ and Qt area, so these people, of course, are very, very welcome here. And the overall goal, so without putting this now very, very negatively, so the final goal is to make yourself redundant. So what do I mean with this? So if some of us, if one of the co-developers decides to quit the project, okay, as it was the case for a couple of other examples I mentioned a couple of minutes ago. So if this person disappears for some reasons, okay, so there must be somebody else in this project, in this community, who can step in and take over basically what you were doing before. Okay, so it's like you know, so the hard disk in your computer. So if your hard disk crashes and if you don't have any backup, if you don't have any possibility to restore your data, to replace the hard disk, okay, your system is more or less done. And this is something that you can also apply the same arguments to the maintenance of such open source projects. So if you want to go long, if you want to have a healthy maintenance for a long period in time, you need to make sure there's somebody who can take over your activities. Of course, all these things mentioned here, this additional work into the promotion, documentation, and so on, this results in additional work and additional effort for the maintenance. As I mentioned before, you know, so 1-2 developers that need to do a lot of development, need to write hardcore code, so need to write a code that is not always trivial, okay, and then on top of this work, you need to also work out all the other points I mentioned above. So this basically results in additional work and effort for the maintenance, at least in the beginning, until you manage to organize additional manpower here. Okay, but without doing this additional work and without doing this additional effort, I simply don't see how to change the overall situation. So as I mentioned before, so right now, healthy situation, we continue working on the project, but it's clear to everybody, to all of us, so this can go on like this forever. There will be a point in time where we need to quit and where we need to hand over to somebody, and then there must be somebody who can take over these activities. Yeah, at the end, it's now about finding the proper balance between doing the development work and finding enough time to do the promotional part of the project maintenance. So the last slide in my presentation, I mentioned multiple times, you know, we have not enough time, or you know, having enough time is a problem. It's a critical factor for people contributing to open source projects and projects having a non-trivial amount of features. So now we need to invest into the promotion. So finding time for the promotional work is a bit hard, and if you manage to find some time for this, so we want to be as effective as possible. Okay, so at the end, it's all about being more effective, using the time you have, and then producing the biggest output out of it. So what I'm showing here are 2 tweets from the last year. So in the past, we only published something on our homepage when we did a release. Okay, so there's a release announcement, so new release is available. We write a big blog post introducing all the new features available in the new release, and this strategy we decided to change. So now we basically report every couple of weeks on the current development activities. So if there's a new feature that landed in master, so we introduce this, you know, so we prepare a new blog post, we tweet on Twitter, we with the help of the KDE promotion team, we distribute this information through multiple channels. And what you see here on the left-hand side is a tweet published last year where we introduced a new feature that was finalized back then. So this feature was around this, what we call info element. Okay, with the help of this feature, it's possible to attach a label to your data point, and then this label basically keeps the position while zooming in, zooming out in the plot, while doing different navigation here, and then you can modify all the properties of this info element. Okay, so this kind of feature was introduced last year, finalized last year, and then we wanted to write an article about this. Okay, and usually, so we try to find a good example for the data visualizing our application. So in this concrete example, so I chose the data for the distribution of the hydrogen in our galaxy. So what you see here, so the 3 peaks are basically, so the measurement 21 centimeter emission line of the hydrogen is measured in a certain direction relative to our position, relative to our solar system. And as you know, so our galaxy has a spiral form, and into the direction where this measurement was done into, so we basically we probe this emission coming from the 3 spiral arms. Okay, because of this spiral arms having the different velocities because of the Doppler shift, so this emission line is shifted. Okay, and these 3 spikes you see, these 3 peaks you see here, basically they correspond to the 3 spiral arms of our galaxy that are visible from our solar system. Okay, so very, very nice example, very nice physics behind this. So I really liked this example. I was proud of it. Okay, I was really, really proud of it. And then on the next day, we produced another tweet. So this was kind of a fun tweet where I did a picture of my workspace of my desk. Okay, and then we invited our followers to a small quiz. So we asked to identify 12 KDE related things. So what you see on this picture is my cat. So he was a bit aggressive at this point in time. He aggressively refused to leave the desk. Okay, since I didn't have enough time for this activity, for this photo session, and I didn't want to escalate the situation even further, I decided to leave him on the desk and then do a picture with him. Okay. Well, this tweet with the cat brought us 4 times more attention, views, and impression on Twitter. Okay, so apparently having a tweet with a cat is more popular, more attractive than talking about the distribution of the hydrogen in your galaxy. Okay, so this is a lesson to learn from this, and maybe this is also the recommendation for everybody who is tweeting. Cats seems to be very, very popular on Twitter. So if you manage to incorporate cat in one of your tweets, attention impressions are guaranteed for you. Okay, so kind of a fun fact, and I think this is also the last slide in my presentation. So thank you everybody for your attention. So I think we still have some time for questions, and if you are watching the recording now and would like to reach out to us asking questions, so this is the link to our homepage. Multiple ways are documented there how to reach out to us, and I think so using our room on metrics and KDE's metrics is maybe the most easiest, most comfortable way to get in contact with us. Thanks, everybody.
Yeah, there is one question in the shared notes if you can take it.
Have you found any correlation between software internalization and code contribution? To be honest, not. I mean, of course, we know, so I mean, by checking the statistics, we know into which languages the software was translated, and we have a couple of, so at KDE, we have a couple of translators who are more active. Okay, so we have software, KDE software is translated in some languages, to a better extent compared to other languages, but this doesn't mean, so we have more contributors. Yeah? So we have maybe 1 or 2 persons doing this, and they simply have more time here. okay, to do this work. And so with respect to coding, to writing code, I also don't see any relation, any correlation, any interdependence between the different languages internalization we are supporting and the code contribution. No. So this next question being written down right now: which activities did really help attract people to the project? So this year we started trying to quantify the success of this project, okay, by monitoring the number of downloads, checking statistics for Linux distribution, checking the number of downloads from the Microsoft Store, FlatHub repositories, and so on. Okay, so we are still in the process of defining metrics that we will use to quantify basically the success. Okay, right now I would say, so the personal impression is publishing more, producing more noise around your project. So publishing something on the homepage, providing additional documentation, nice examples, and so on and so on. This is what helped to attract new users. And right now we measure this basically by the number of emails, personal emails we get by the user, number of bug reports, feature requests, and so on and so on. So right now I would say the promotional work we did in the recent past brought us more attention, more new users than the new features we released recently. Okay, and this is the reason why I said, okay, so there's a certain change in the mindset happening right now, where we say now, okay, so the level of maturity of the project is maybe good enough now, and so the application is usable for many users coming from many different academical communities. So we simply need to reach out to them to introduce the project and try to attract new users. Okay, and this is what is happening right now. So we see new users coming and getting in contact with us. So promotional work definitely is had the heaviest impact in the recent past.